All right, let's take a look at a special case of a rational function where there is actually going to be a common factor that's present. And this actually will identify a scenario called a point discontinuity, also known as a hole. So I'm going to show you what this kind of looks like. If you actually factor out f of x here, it's x squared minus 4 over x plus 2. We want to sketch this. Well, if you factor this out, you can actually write this as x plus 2 times x minus 2 over x plus 2. And you can notice that there is a common factor. Just off the bat here, we can understand that there is a very important restriction. If x can belong to all real numbers for your domain, but x cannot equal negative 2, okay? And if x is negative 2, look what happens. We basically get negative 2 plus 2 here is 0, and negative 2 plus 2 here is 0. So we get 0 over 0. This actually does not represent a vertical asymptote. This is actually what we call an indeterminate state. Right, and the indeterminate state actually represents something called a point discontinuity. So it's a missing point, and the point discontinuity is also known as a hole, aka a hole. Okay, so this is a missing point in the function. Now, if we wanted to actually solve for this, we can actually simplify the expression, and we can see that it looks like x minus 2. We know that x minus 2, if we're looking at f of x is equal to x minus 2, this should be a linear function, right? So you can think about this as slope-intercept form, mx plus b. So this is the point, the y-intercept is 0 and negative 2, and the x-intercept, if I just let f of x equals 0, we get x minus 2 is equal to 0, so x is equal to 2. So the x-intercept is 2 and 0. Based on this, we can actually draw out a line. Now, we stated that f of negative 2 would not exist, right? But in our simplified state, we can actually plug this in. F of negative 2 should not, therefore, equal negative 2 minus 2, which is negative 4. So the point that doesn't exist is negative 2 and negative 4, and this represents the hole, right? So the way you can figure out the hole, the value of the hole, you simplify the function first, you get the simplified expression of the function. So in this case, it's x minus 2. We know that x cannot equal negative 2, but if I do plug it in, then if x cannot equal negative 2, then negative 2 and negative 4 shouldn't exist. So this is where the hole exists. And I'll show you guys what the hole looks like. But if the negative 4 doesn't exist, then the range of this function, right, y belongs to all real numbers, but y shouldn't be equal to negative 4. Good? So it shouldn't also be equal to negative 4 because there will be a hole of the function, right? And because it's a linear function, we would expect to see that there is going to be one y value for a given x value. Now this would be different if you have a parabola, but there's only going to be one y value for a given x value. Now if you wanted to sketch this, right, we can understand there is no asymptotes, right? A hole is not an asymptote. Okay, so there's no asymptotes because this is basically going to be a linear function. And if we want to find an intercept, well, we already just found the intercept because it's a linear function. So the intercepts are correlated with this linear function. Okay, so we already did part C. And let's take a look at what the sketch will look like. Okay, so I'm just going to create my grid system here. Okay, so on my grid system, I'm going to plot the x-intercept 2 and 0. Somewhere here. And we also have y-intercept 0 and negative 2, somewhere here, right? And all we have to do now is we construct a line, but we need to note that, so this is our line, right? But we need to note that negative 2 and negative 4 is our hole. So this is actually a missing point. Do you guys see that? Right, so this is actually a missing point. So that's how we can represent a hole. We just do this open circle here, right? I think I overly exaggerated it, but right, so we have this missing circle here, and that represents a hole. But beyond that, it's basically will look like a linear function, right? And that's basically what our graph will look like, right? So it's pretty straightforward. Last thing we want to do here, let's describe our end behaviors. Right, as long as x does not equal negative 2, as x approaches negative infinity, as we go this way to the left, right, then y is going to approach negative infinity. And as x approaches positive infinity, as we're going this way to the right, y is approaching positive infinity. So opposite end behaviors is what it looks like. And this is basically how we can analyze a function that does have a point discontinuity, or also known as a hole.